Hi, in this video we're going to look at how we can take a set of forces acting on one object and work out the resultant force. All the resultant force is the sum of all the forces. So to work out the sum, we're going to turn the forces, first of all, into column vectors, resolve them like we did last video, and then add those column vectors together. A little bit of theory first then. Resultant force is just sigma F. Sigma here, Greek S, S for sum, the sum of forces. All you do is you add up each of the forces as column vectors. So the resultant force is going to be a vector, and it comes from adding together how many forces there are. So there's 3 forces, add 3 together. There's 4 forces, add 4 together. They need to be written as column vectors. You can't add together the size of the force because the direction matters as well, right? So that's why we're turning it into column vectors in the first place. Let's have a go by looking at a first example. There's 3 forces here. We'll start with the forces that are along the x-axis and the y-axis because they're a little bit easier to resolve. Let's look at this 40 newtons first of all. This is going entirely along the y-axis. So there's nothing acting in the horizontal direction at all. There's nothing in the x direction. It's entirely downwards, right? So it's got nothing in the x part. It's just going down. So it's going to be 40 in the y part. And since it's going down, not up, it's going to be a minus 40. Think of it like a coordinate. This is like minus 40 on the y-axis. This one over here is on the x direction only. There's nothing in the vertical. There's nothing in the y part. So it'll be 0 in the y part and 20 in the x part. And again, since it's going towards the left, not the right, it's going to be a negative 20 because we know going towards the left is negative x direction. This force up here needs resolving, so I'm going to draw a slightly bigger bracket. I'm going to put some causes and some sines in here. I'm going to have 10 cos 15 to work out and 10 sine 15 to work out. If you remember from the last video, the way you did that was by drawing in a triangle and then looking at which side was cos. Was it the x direction that was cos or the y direction that was cos? And we said that it was cosing up to, it was adjacent to the x direction. So it's going to be 10 cos 15 in the x direction. So 10 cos 15 goes just there. It's cosing up the x axis, so cos in the x direction. That means the other side is going to be sine, because that's the opposite. And this came from that triangle, remember? We have the triangle with sine theta here and cos theta here. And if it's a 10 size triangle, it means the whole triangle is 10 times bigger. So 10 on the sides. And if the angle is 15, it's going to be 10 sine 15 here and 10 cos 15 just there. Be careful here. We do need to think about sines. So because this is going positive, positive is going to the right and going up is both positives. If you're not sure about this resolving, go back and check out that other video if you haven't seen it already. The next thing to do is to work out the resultant force by adding together all of these forces. So one at a time, let's write them down. All we do is add them up. The resultant force is just a sum of forces, the resultant you get from adding all the forces together. So now all I do is add the tops together and add the bottoms together. Tops is going to be minus 20 plus 0 plus 10. So minus 20, no need for the 0, and then 10 cos 15. If I have a calculator, plug in a calculator and get a decimal number here. I don't particularly need to. It's still a number, right? It still works. The bottom is going to be 0 minus 40, and then plus 10 sine 15. You may be desperate to work out the actual numbers there. Most students in year 12 and year 13 are. However, most questions we're going to do are going to have some algebra and stuff involved, and so it's unlikely you're going to get exactly a single resultant force. You get some algebra in there. So I'm not desperate myself to work out the values. I'm going to leave it alone. Let's look at one that has got some algebra. This one here has got some T's and W's. Let's see if we can work out the resultant force for this question. Usually in a question, as we see in the next video, you'll be putting this equal to something and trying to solve it. So there's only part way through what we need to be able to do a question. Well, where should we start on this one? Let's start with the ones that are going horizontal and vertical, because they're the ones that are along the axis. They'll be the ones that have these zeros like last time. So we'll start with the 12 Newton force here. That's along the x-axis, so nothing in the y-axis, and 12 in the x-axis. And it's going to be positive 12 because it's going towards the right. This 17 is going on the y-axis, so nothing in the x-axis. So 17, other way around, nothing in the x-axis, 17 in the y-axis. And again, it's going to be a positive one because it's going up. W here also on an axis. So this is going to be 0 in the x and W in the y because it's not going in the x, it's going straight down. It'd be a negative W because it's going down. And then finally, T, we need to write that down as a vector. So let's a bit of space. I'm going to try not to draw the triangle in this time because as we go on, there's going to get more and more triangles if we're not careful. It's going to get really cluttered. We won't be able to do it without drawing triangles in. So I'm going to think here that T is cozying up to the x-axis. So T cos 40 is going to go in the x part, and T sine 40 is going to go in the y part. And then I'm going to think about signs. So because it's going towards the left, it's going to be a negative for the x part, and it's going upwards, it's going to be a positive for the y part. This, call it here, would be negative x, positive y, imagine kind of where it would be lying on the axis. To get the resultant force, what I do is add these forces together. So the resultant force is just going to be, can I do this in one go, you think? This force, T cos 40, T sine 40. Then we can add to it, these are the forces, so plus 0 minus W, plus 12 plus 0, and then plus 0 plus 17. Rather than writing it out as being separate, I can just write it out as being one long list. It's the same thing, right? And that is my resultant force. Of course, some of these zeros we can get rid of, but it doesn't change the value, right? The last one over here, again, start with the ones that are on the axes, get them out of the way. This 50 newtons one is along the y-axis, so 50 on the y, 0 on the x. Think about signs. Yeah. So every time you write down a force, pause and think about minus signs. They're the easiest things to miss. It's going to be minus because it's going downwards. T1. So T1 we've got is cozying up to the x-axis. So it'd be T1 cos 20 in the x and T1 sine 20 on the y. Think about signs. It's plus for the x and plus for the y. It's in the positive part for both the x and the y. It's going right and up, so both of them positive. Now T2. Again, it's cozying up to the x. T2 cos 60, T2 sine 60. So cos is going in the x part because it's cozying up to the x. Think about signs. Negative in the x direction, positive in the y direction. It's going left and up. Or you can think about the fact that it's on the negative x coordinate and a positive y coordinate, that helps. And then finally, to get the resultant force, I've just got to add these forces together. Do I have space for that? Perhaps if I move this force slightly up, I can make a bit of space in there. The sum of forces, this thing is going to be, let's start with this one, minus T2 cos 60, T2 sine 60, and then this one plus T1 cos 20 plus T1 sine 20, and finally this one plus 0 minus 50 close bracket. And that's my resultant force for these three examples. Now we can work out resultant force. We're really motoring. The next thing we can do is actually solve a question. So we can put all the things we've done together, start putting these resultant forces, equal things, start to solve these equations and find things, get on to actually doing some pure maths. So I'm excited about that next video now. Hope you enjoyed, hope it's useful. Check out the next video.